Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use TIA Portal version 16 to connect with the PLC S7-300 CPU 314C to PN/DP. Okay. And in this section, I will show how to scale the analog input for this channel, and I will explain about how to wiring step by step before we start with the TIA portal. Okay. So first, we need to have the current loop calibrator or current loop source, and we series with the milliamp meter to measure the milliamp that source from the standard source to the module. Okay, and I will use the Profinet port for connect with my PC by using the TIA portal. Okay, so before go to create the program, I would like to show about how to wiring, and I will explain step by step. Okay, so let's go. So here the drawing that I already explained in the previous video about how to connect the encoder, but in this section we not discuss about encoder, but we discuss about the analog input module. Okay, so here is the CPU 314C to PN/DP, and here is the memory card, and here is the switch stop and switch run, and here is the Profinet port, and here is the terminal blocks that we will connect the power supply 24 voltage to the CPU. Okay, and for in this CPU it has only one for Profibus port. Okay, and here is the analog input. Totally there are 5 channels. That 4 channels we can select the option milliamp or volt, yes, that we want. And here is the drawing how to connect. Yes, if we would like to use with the volt, we can connect with the terminal 4 and terminal 2, and if we would like to use the milliamp, we can connect terminal 4 and terminal 3. Okay, for channel number 1, and for channel number 2 we have 3 terminal also. So the first one is terminal number 7. We can connect the voltage, the common, yes. And for terminal number 6 we can connect milliamp, and if we would like to use the volt, we can connect the terminal number 5. Okay, and AI1 to AI4 is the same function that I already draw the terminal number, so we can connect follow this one. But for the last one of analog input, it is the input with the PT100 or ohm, yes. So we cannot use volt or amp, but we can use with the PT100 or RTD. Okay, so it is the special channel, and we will check the address when we create the hardware configuration on the TIA portal. Yeah, and I will explain more about this step. So right now here is the wiring connection. Yes, so we need to know about how to wiring before we test the module. Okay, so let's go to our software to create the new project of TIA portal and test with the real PLC. Okay, so let's go. Okay, here is the TIA Portal that I already installed in my PC, and the previous video we already learned about encoder, and for today we will learn about how to scaling AI, right? Scaling analog input. Yes. So let's go to open the TIA Portal version 16, and I will explain step by step about how to configure the hardware configuration and check the address and create the scale, or we can use the library of scale that we want. Okay, so let's follow me step by step. So the first step, we need to create a new project. So let's create the new project here. Click, and then this is a project name, example scale AI. Yes, and here is the project file location that we would like to keep. So I will browse to keep on desktop, and then go to scaling AI that we already created the folder. Yes, and we will click create. It will create the project automatically. Yes, and then we will create the hardware configuration. Okay, so let's follow me step by step, because it is the basic of TIA. Okay, so wait a moment for creating the project. Yes, so right now let's go to project view. Yeah, and then we need to create the hardware configuration, right? So to create device, let's go to add new device, double click, and then go to controllers, go to PLC S7-300, right? Because right now I use PLC S7-300. Yeah. And then go to see the CPU 314C2PN/DP here. Yes. And here is the picture of device. And here is the serial number. Yes. And here is the version. So we can click OK. The hardware configuration will insert automatically, and then we will go to see the property of the analog input that we will test with the real PLC. Yes. Okay, so we already created the hardware configuration here, because this CPU it built in the input and output. Yes, with the CPU. Yeah, and we can zoom a little bit, zoom in. Yes. Okay, zoom in a little bit. Okay, so it is the analog input card, and here is the digital input and output module. Yes. So in this section we not discuss about the digital input and output, so we discuss about analog input only. Okay, so let's go to property of the device. Okay, go to property of the device, and then let's see here. We will find the channel number 0 until number 4, because there are totally 5 channels, right, that I already show in drawing. So the first one is channel number 0, so we can select the option for milliamp or volt that we want. So basically I will select to current, yes, and my current is 4 to 20 milliamp, yes, and for channel number 1 I will select 2 current also, 4 to 20 milliamp also, because I have only a standard saw with the current. Okay, so I will select all input with the current. If everyone have the volt, yeah, use with the input volt. Example, the VFD use the volt, so we can select here volt, and wiring the connection follow my drawing, yes, follow here. If we would like to use the volt, so we need to use the terminal 4 and terminal 2, and for the option we can select here, yeah, 0 to 10 volt or plus minus 10 volt, yes, but in this case I will select to current, yes, and this one channel number 3 is current also, and for channel number 4 it has only 2 options. The first one is resistance 2 wise, and the second one is thermal resistance 2 wise. Okay, so we can select like this first, or we can select with the standard PT100 or RTD like this. And for analog output we will discuss in the next video. Okay, so right now the option we already created, so we save the project, and then let's go to connect my LAN cable from the PROFIBUS here to my PC, and we can use the command prompt to ping 192.168.0.1. sorry. Okay, we can ping. If everyone cannot ping, let's go to see the Ethernet. Yes, we can put the manual of Internet. For me, I already put the manual. Yes, provide the manual for IP4 here. Yes, example 192.168.0.253. Yes, so we can ping. It means that we can communication between the PLC and PC. Okay, so we can go to select the CPU and then go to download to device. Yes, download our configuration to device before create the logic. Yes, create the scale. So here we can select the PROFIBUS, and then here we can select the network card that we already put the LAN cable. Okay, for me I select this one because my network card is here. So we can go to start search. It will detect the one CPU here. Let's see here. The device type is CPU 314C2PN/DP, and for the IP address is here 192.168.0.1, the same as I ping. Yes. Okay, and then we can load. Yeah, it means that download the hardware configuration to the PLC. And for the hardware configuration download, we need to stop the CPU. Yes. So waiting for compile the program, and then let's stop all. Yes. We can select no action and stop all. In the first time we need to stop all, so click load. And then we will start the CPU again. Yes. I will show if we press the finish, the CPU will start automatically start. Okay, let's see. Right now the CPU is stopped. So if I select finish, the CPU is warming start. Yes. Okay. And then we can go to create the scale, right? Okay. Before go to create the scale, I would like to explain a little bit more for the address. So we can go to the PLC hardware configuration and then go to property again. And here is the I/O address. Yeah. So it will start from address 800. Yes. 800 until 809. Yes. So for analog input, it will start from PIW 800. Yes. PIW 802, 804, 806, 808. Yes. Until 809, right? Totally 5 channels. Okay. So we can go to create the block. Yeah, program block. Go to the program blocks. And then go to the main program. And then go to the scaling, right? Actually, we can use from here. We can search for scale. Yes. If we search, we can go to see the scale or unscale here. Yes. It is the convert operations. Yes. Conversion of operation. So basically, we can use the scale here, drag and drop. Yes. We will got like this, block like this. So we can command the network, example scale analog input channel 1 connect with temperature transmitters. Okay. Okay. And the scale is example 0 to 150 degrees Celsius. Yes. Okay, it's just example. Yes. So here we can use the address that I already show. So it will start from PIW 800, right? PIW 800. So here we can command the text. Example sensor 1. Okay. And here is the high limit. So high limit we can use 150.0. And for the low limit we can use 0 to 0.0. And for this bipolar we can use the hell. Yeah, I will show. Okay, press F1 to see the hell. The software will explain us about how to use the scale. Yeah. So let's see here. It is the parameter of the scale. So the first one is EN. It means that enable input, enable output. ENO. In it means that input value to be scaled. Yes. So it can integer, yes, and here is the real for high limit, yes, low limit, it is the real also input, and for the bipolar, yeah, here it is the Boolean input also, and the software will explain us indicate if the value at the in parameter it is to be interpreted as bipolar or unpolar. Okay, the parameter can be assumed the following value. One is bipolar, it means that the Boolean true or 1, and 0 unpolar. Okay, and here is the output. So the output is the real, yeah. Example, the temperature 0 to 150 degrees Celsius. So it is the real. It has the decimal place. And read val, it means that the error, yes, error information, it is the word, and it is the output also. Okay, and here is the platform of the scale, yeah, then we can read. Okay, let's go back to our scale block. So here we can use M0.0, example the option, yeah, option bipolar or unpolar and bipolar. Okay, and here is the error value, right? So error value we can use MW 100. Yes, it is the error value, right? So we can use error value for channel number 1. Okay, and here is the output. The output is the real, right? So real we can use MD, example MD10. Yes, it is the real, right? So example temperature 1. Okay, then we can save the project and we can download the logic to the CPU again. Okay, download to device. Here we can select console to download and we can load, and then we can go online to see the status. Yes, okay, go online to see the status. And then it will show the status for us. Okay, let's see here. The milliamp is half because I already connected the standard source, yes, current loop to the terminal. So let me show. Okay. So we can adjust the milliamp to 4 milliamp. Yeah, 4 milliamp it is 0, right? 0 it means that 0 degrees Celsius. So if I would like to adjust to 8 milliamp, yes, 8 milliamp, it will show around 27, right? 37, sorry. 12 milliamp. It will show around 74, right? Okay. 16 milliamp. It will show around 112. Yes. If I select to 20 milliamp, it will show around 149, nearly 150, right? Because the error a little bit for my current loop. Actually, this one should be 22,648, right? Let me adjust little bit, okay? Because it is error little bit. So if we would like to decrease, we can decrease. Yeah. Because now I only connect to channel number 1. Let's see the wiring. Yes. So it's working properly for channel number 1. And if we would like to connect to the other channel, we can also connect. Yes. So if we would like to connect to other channel, can go offline and then go to the scale. Yeah, one more scale. Actually, we can use drag and drop to here, and we will got one more scale. Okay, so this one should be a PROFIBUS-DP, right? It is the channel number 2, or we can write command sensor 2. And example scale, high scale from 0 to 100 degrees Celsius or 100 bar. Yes, this one should be M 0.1. Optional also, right? Example option bipolar 2. Yes, here MW 200. Yes, it is the error for channel number 2. And here we can use example MD20. It is the temperature number 2. Yeah, temperature 2. Then we can go online and then go to download. Okay, and we can go the monitor to see. Let's see, right now the connection is not yet connect, right? So I will connect the milliamp to the channel number 2. So channel number 2 is terminal number 7 is minus, number 6 is plus. Okay, so I will disconnect from channel number 1 and then connect to channel number 2. Okay, right now I already connected the cable. Number 7 is minus, number 6 is plus 4 milliamp. Then let's see here again. Yes. Let online again. Maybe we can use with the network number 2. Yes, I will cut to network number 2. paste. This one should be channel number 2. Scaling. We can cut, and then we can paste. We can save, and we can copy from here. And then paste here. So this one is channel number 2. Then the temperature is 0 to 100 degrees Celsius. Yeah. So we can save the project and then download to the CPU again, because we change the network. Then we can online. Okay, let's see here. The temperature show around 24 degrees Celsius for channel number 2. And for channel number 1, I already disconnect the cable, so it go to 0. Yes. So if I adjust the milliamp, yes, let me show the connection for channel number 2. Okay, for channel number 2, I already connected the cable, yeah, to number 7, terminal number 7 and number 6. And if I adjust to 12 milliamp, let's see, the temperature show around 49, 16 show around 74, 20 milliamp show around nearly 100 degrees Celsius, right? Okay, so channel number 2 is working properly also. Yes. So if we would like to connect to the HMI, we can also insert here. So I will go offline first. And then let's go to the HMI, right? Let's go to add the new devices. Go to HMI. And example, I will use the comfort panel. Yes, this panel. Because we need to show the analog input on the HMI, right? For example, the temperature. Yes. So we need to show on HMI. So I will select the PLC here. Okay. And then click finish. Because we connect to the PLC S7-300 and 400, right? So wait a moment for creating the project of HMI. Yes. So basically we can use like this, and for that we can delete or we can keep. Yes. And this one we can modify to be go to the text, and then go to the general. So here we can write another word that we want. Example, we are learning about scaling analog input with TIA Portal version 16. Yes. So we can write like this. And if we would like to increase the size, yeah, we can also increase. And if we would like to change the color of background, we can also change the color of background. Example to this color. And for the text, we can also choose another color that we want. And then we can adjust the area. Yes. Then we can align to be center. So the first step, we need to create the text, right? So let's go to the connection to see the connection that we connect from the PLC S7-300 to the HMI, right? So let's go to the text here. Because we need to insert the text, right? So I will add the new one, example sensor 1. So it is the real, right? It is the real, right? So it is the connection. Yeah, we can choose the connection of PLC because we need to use the PLC, right? And for the address is let's see here. For the address, for channel number 1 is MD10, right? And channel number 2 is MD20. It's just example. So I will choose this one is so MD10, right? Okay. And for sensor number 2, I will use MD20. Yes. So that's all for create the text. And the next step, we need to go to the root screen to create the screen, right? To show the value of the temperature. So example, we can use the input file here for sensor number 1. So here we can choose the text that we already created for sensor number 1 here. Yes. And for the text format, we can use another format that we want. Example, for the font size, I will change to 25. Yes. And the alignment, I will set to central and middle. Yes. Okay. And for the format, let's go to see the format like this. Example .99. Yes. So it will come to like this. And we will go to the layout, apparent. We can change to another color that we want. Example, this color. And for the text color, I will change to the green. This one I will change to black. It is the black, right? And for the outline, I will change to white. Okay, like this. And for the text, I can copy from here for the unit, right? For the unit, I will change to the degree Celsius. Yes. I will adjust the size to be 15, yeah, for unit. This one I will change to 27 something, yes. So for sensor number 1, we can copy, yes. For sensor number 2, we can copy and paste here. For unit, yes. And for the text, we can also copy. Yeah, it's for sensor, temperature sensor. Temperature sensor 1, yes. We can adjust the font size a little bit. And we can align this one to here. Okay, and then we can adjust to be 32, 27, 25, yes. Okay, and then we can copy for sensor number 2 here, and we can change the color to white color. You can select by click shift and then go to the color, right? We will change the text to white color. Apparent, so we can change to the white color. Okay, and then we can save. And for this sensor number 2, we can go to general to change the text to be sensor number 2 here, and then we can save. And let me check the connection again. Okay, so we can simulation. Yes, go to simulation here. Okay, wait a moment for processing the simulation. Oh, here we can adjust. Yes, adjust the location a little bit. Adjust to be here. And here we can adjust also. Okay, this one we need to adjust also. Okay, and then go to save the project and then simulation again. This one, right? We will adjust. Maybe we need to decrease the size. Okay, so we can simulation again. Okay, that's good now. So we can go to the main program and then let online to check the status, the real status of the PLC and then the HMI. Yes, let's see here, the temperature is show around 49 degrees Celsius because the milliamp I select to 12 milliamp. Let me adjust the milliamp. So if I adjust to 8 milliamp, the touch screen is show around 24 degrees Celsius. Adjust to 12, 49 something, 16, 74, and 20 is nearly 100 degrees Celsius. Okay, so it's working properly. Yes. So this is just example about how to use the scale analog input on the TIA Portal version 16, and also simulation with the HMI. Yes, that I already showed step by step about how to create the project, how to create the scale. Yes. So I hope this video is useful for everyone for basic configuration the hardware and test with the HMI, right? So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye.